Good morning. Morning, good morning, good morning. Morning online class. Huh? Okay, so I think I gave one problem and most of you have given the answer. Who will tell what was that problem? Nobody is responding. 2 alpha. Okay, answer was the 2 alpha. So everybody has done. Otherwise, I have to discuss it. It need to discuss or everybody has got done. Okay. Okay. Say, sir. One is saying done, one is saying say. Okay, I will say no problem. Problem was what? A liquid is filled in any container and the gamma of the container they have given alpha of the container they gave alpha. Okay, coefficient of linear expansion of the container they gave alpha and liquid expansion coefficient they have given gamma. And they are asking the relation between gamma and alpha with the condition that when you are passing the heat, then height of the liquid column is not changing in the container. Okay, so height of the liquid column is somebody may is thinking that it is a completely filled. Okay, so when it is a completely filled also, then if the container get expand, then it will get expand like this. But liquid is not occupying the whole space. Okay, height of the liquid we have to take what? Height of the liquid is same before heating and after heating. Okay, that was the question. Means on heating, height of the liquid column is not changing. Then what is the relation between gamma and alpha? Somebody says that gamma is equal to 3 alpha. Gamma is equal to 3 alpha. That is valid for the solid. Like alpha is to beta is to gamma is equal to 1 is to 2 is to 3. Gamma is equal to 3. Alpha is not defined for the liquid and gases. Why? Because there is a no linear expansion in the case of gases and the liquid. Okay. So directly you cannot write gamma 3 alpha. Now here what we will do, if I ask what is the initial volume of the liquid, suppose that height I am taking H and the area of the container I am taking A. Okay, then initial volume what we can say, A into H, area of the container into height. Okay, so that is the initial volume, we can say it is the initial volume of the liquid. Okay, now on increasing the temperature, what will happen? Container will expand. Okay, so area of the container will expand, and but height of the liquid column will remain same. So I can say the delta V of the liquid, that is equal to what? Change in the area of the container. Okay, like suppose container get expand like this. So that extra is what? Change in the area of the container. So change in the area of the container into height. Height is not changing, so that's why here what we will take? H. Up to this, any problem? Okay. So I am asking the change in the volume of the liquid. Change in the volume of the liquid is what? Here height is not changing, but area is changing. So area, suppose change of the area in a container is delta A, then delta A into H. Okay. Now delta V I can write as delta A. Delta is a change in the area of the container. Container is a solid. So for that I can write as a delta A is equal to what? A beta into delta theta. A beta delta theta, solid, we have learned that, into H. Okay, beta we can write as 2 alpha. Then delta V is equal to what? A into H. A into H is the initial volume. Beta I can write as a 2 alpha into delta theta. Okay, then I can say delta V upon Vi into delta theta. That what you will get? 2 alpha. This is what? This is what? Change in volume upon original volume into delta theta. That is the gamma of a liquid. So gamma of a liquid, what we can say? 2 alpha. Okay. Got it? Okay. Now, one more thing, this similar type of problem. Suppose I am saying any container, it is containing some liquid and some vacant space is there. So that vacant space is occupied by the air. Like suppose the container is filled up to this. So vacant space is occupied by air. So on heating, suppose they are saying on heating, volume of the air is not changing. On heating, volume of air is not changing. Then what you will do? On heating, volume of the air is not changing. Then what is the condition we will have? So in this case, what will happen? Like suppose container volume is the VC and the liquid volume is the VL. Okay. So VC minus VL. VC minus VL is what? Vacant space. VC minus VL is the volume of air. Okay. That will be the volume of air. Okay. Now they are saying on heating, what is happening? Volume of the air is not changing. But what we know, on heating, on passing the heat, container will expand and liquid will expand. But volume of the air should not change. So what is the condition? We have same type of question we have done in a solid also. So when they are saying the volume of air is not changing, so whatever the expansion the container will have, same expansion liquid will have. So like suppose container expand by delta V. Delta VC I am taking, okay, and liquid expand by delta VL. So it must be constant, means what was initial? VC minus VL. So it must be equal to what? VC minus VL, okay, because they are saying the volume of air is not changing. So volume of container change, volume of liquid change, but their difference must be constant. Then what we will get here? Delta VC is equal to delta VL. Means expansion in the container must be equal to the expansion in the liquid. Understood or not? So when they are saying the volume of the air is constant, then we can apply what? Delta V, or increase in the or change in the volume of the container is equal to the change in the volume of the liquid. Okay? Everybody got or not? If volume of the air is constant. Okay, so one question we can do on this. If container volume is 1 liter, contain mercury, okay, on heating, volume of air is not changing. Then find volume of initial volume of mercury. If gamma of mercury is the 1.8 into 10 to the power minus 5 per degree C minus, and gamma of the container is the 2.7 into 10 to the power minus 5 per degree C. Okay, if the container volume is the 1 liter, it contains some mercury. Okay, what is the volume? They have not mentioned. On heating, volume of the air is not changing, then we have to find the initial volume of the mercury in the container. Gamma of the mercury I have given and gamma of the container I have given. Okay, one answer I got 0.15 liter. Good, good. Any other? 0.15, 0.15. Very good. So means I think 0.15 is the answer because everybody is getting 0.15. Good. Okay, so here directly we will say what? Delta V container, that is equal to delta V of the mercury. So delta V container means we can say initial volume of container 1 into gamma of the container they have given 2.7 into 10 to the power minus 5 into any temperature we are changing by delta theta. That is equal to delta V of the mercury. Suppose initial volume of the mercury I am taking X into gamma of the mercury, that is a 1.8 into 10 to the power minus 4 into delta theta. Delta theta cancel out. From that you can get the value of X. So everybody is getting 0.15. X value is the 0.15 liter. Okay. Okay. Completed. Next is the effect of temperature on density. So this topic already I discussed in a solid. Okay, who will say what was the formula? Like I said, first what we have to take, they have given the initial density, and they are asking the density at any temperature. Most of the cases, sometimes what happens, they take the initial density, we take as a, they have given the data. So initial density we take at 0. With respect to 0, we find the change. When we are increasing the temperature, we can take delta theta as the theta minus 0. Okay. D1 is equal to D2 upon 1 plus gamma delta theta. So the same formula here we can write density D by changing temperature delta theta. So rho, what we can say, rho naught upon 1 plus gamma delta theta. Rho naught was the initial density. Rho was the density after changing the temperature by delta theta. If delta theta positive, so density will increase. Delta theta negative, so density will decrease. Okay. And I said always first we will go through this formula, then after that we will check. So I think one question I discussed, what is the change in density? Change in density question I discussed in the solid. Okay. So the same type of problem we can do here also. Okay. So one question we'll discuss on this. So little concept of the hydrostatics required. I will say no problem. Suppose I have the U-shaped tube. Okay. It is containing the same liquid, but this side of the arm I am maintaining the temperature at 0 degrees C, and this side of the arm I am maintaining the temperature 100 degrees C. Okay. Here height of the liquid column I gave 80 centimeter, and here height of the column I gave 80.4 centimeter. Okay. We have to find, that is a uniform U-shaped tube. In that we have put the same liquid, but this arm I am maintaining at 0 degrees C, this arm I am maintaining at 100 degrees C. So height of the liquid column I have given here 80, here 80.4. So we have to find the gamma of the liquid. Find gamma of the liquid. Now this we will learn in our hydrostatics, in our liquid properties of the fluid. In a same liquid, if it is a static, so at the same horizontal level pressure will be equal. Okay. If it is the same, like temperature I am maintaining same, if both side temperature is same, then what will happen, the height of the liquid column will be same in both arms. Okay. But here why the height difference we are getting, because this side temperature is 0 degrees C, this side temperature is 100 degrees C. So that's why liquid density will change due to the temperature. That's why we are getting the different height on the both side. Otherwise, same liquid you are taking, same temperature, then their height will be the same. Okay. Everybody got or not? So here what we will do, but it is a static liquid, so on the same horizontal level pressure has to be equal. So at any horizontal level we can equate the pressure. So we can take at the bottom. Okay, because height they have given from the bottom. So at the bottom of the both arm, pressure will be equal. Bottom of the both arm pressure will be equal. Then what is the pressure? We can write here. So atmospheric pressure is the P naught, suppose, plus extra pressure due to the liquid will come H rho G. Maybe you remember or forget. Due to the liquid column, pressure will come H rho G. Okay. So here I can write the pressure is what? One side, suppose I am taking A, one side I am taking B. So pressure at the bottom of A, that must be equal to the pressure at the bottom of B. P I can say atmospheric pressure plus H is what? H1 rho 1 G, that is equal to P naught plus H2 rho 2 G. One I am taking here, two I am taking here. Okay. Then P naught and P naught cancel out. Then G and G will cancel out. So H1 is what? 80 centimeter. Into density rho 1 I can write rho naught. That is equal to what? H2 I have given 80.4. Both are in the centimeter, so no need to convert in unit. Centimeter will get cancel out. And rho 2, what I will write? Rho naught upon 1 plus gamma delta theta. Here 0, here 100. So what is the delta theta? 100. Now rho naught cancel out. So 1 plus 100 gamma, that is the 80.4 by 80. Then from that you can find the value. Who will say what is the answer? So 100 gamma is equal to 804 by 800 minus 1. So that is equal to what? 4 by 800, or we can say what? 1 by 200. Then gamma you will get 5 into 10 to the power minus 5 per degree C. Okay. Understood or not? So what I said, if it is the same liquid, then height will be the same if they are at the same temperature. But why here height difference is there? Because the temperature on both sides of the arm is different. Okay. Completed? YouTube. Okay. Okay. So expansion of water. Water shows the different behavior. I think you have the idea from the chemistry also. When we expand the water from 0 to 4 degrees C, what happens? Volume, when we increase the temperature from 0 to up to the 4 degrees C, then the volume of the water, what happens? Decreases. When 0 to 4 degrees C, volume decreases. At 4 degrees C, volume will be minimum. At 4 degrees C, water volume will be minimum for the given mass. For the given mass, water volume will be minimum. And beyond 4 degrees C, when we increase the temperature, again the volume of the water increases. So means if I am asking for the 0 to temperature range, 0 to any high value, so water volume for the given mass, water volume will be minimum at 4 degrees C, at 4 degrees C. So the graph we got, and this temperature will be 4 degree C. So volume of the water is minimum at 4 degree C. Okay. Less than that, more than that, volume will be more. Okay. Now volume for the given mass, that I am saying for the given mass. No? So if I draw the graph between density and the temperature for the given mass, what the graph I will get? So density is the mass by volume. Okay. Volume is minimum at 4 degrees C. Then what will happen? Density will be maximum at 4 degrees C. So reverse graph you will get. And here density will be 1 cc, 1 gram. In CGS unit, you will get the maximum value is the 1 gram per cc. Okay. So density and the temperature graph will be reversed. So density of the water is maximum at 4 degrees C and the volume of the water for the given mass is minimum at 4 degrees C. Okay. Okay. Okay then. So suppose I am asking, I have the water in any container and it is completely filled. Okay. Suppose I am ignoring the expansion, ignore expansion in the container. If I increase the volume, then what will happen? If I decrease the volume, what will happen? Means water will overflow at what temperature? Suppose it is at 4 degrees C. Water initial temperature is 4 degrees C. If I increase the temperature, then what will happen? If I decrease the temperature, what will happen? If the initial temperature of the water I gave 4 degrees C and it is completely filled in the container. So when I at 4 degrees C, it is at 4 degrees C. It is at 4 degrees C. Initial temperature of the water is 4 degrees C. Okay, I have filled in a container. Container is completely filled. Now I am heating or I am cooling it. I am heating or I am cooling it. What will happen in that case? So suppose you are heating. Heating means you are increasing the temperature beyond 4 degrees C. So we know that when we heat beyond 4 degrees C, volume of the water increases because minimum volume we will get at 4 degrees C. So either I increase the temperature or decrease the temperature. Increase the temperature or decrease the temperature, what will happen? Volume will be more. Volume will be more. So when I am increasing or decreasing, both cases what will happen? Water will get overflow. So whether you cool down this or you heat it, both cases water will come out. Understood or not? Because initial temperature I gave 4 degrees C. Okay. So at 4 degrees C, now 4 degrees C volume is minimum. Beyond that or less than that, both cases water will expand. Expand, then what will happen? It will overflow. Okay. Okay, so this is about the volume, and in the NCERT even they have not given more about the expansion of the liquid. Okay, so that is sufficient. Now next topic is the expansion of gases. Okay, so who will say, like suppose that particular question they are asking, alpha or the gamma of the solid depends upon temperature. Suppose that particularly they have given this. Alpha depends on the material, that is okay. Alpha or gamma depends on the material. But suppose they are asking if for a solid or liquid and gases we will discuss later. For solid and liquid, gamma depends upon temperature or not, or alpha depends on the temperature or not, or gamma depends on the temperature or not. So in a solid, gamma depends on temperature or not? Depends on temperature. One graph I said, remember, no, copper graph I said. So copper means they have only given one graph of the copper, but other material also they will show the properties, because like only copper they have given the graph, it doesn't mean that copper alpha only changes, gamma changes only with temperature, because when we are heating any solid, so density will change, material property will change. So that is no any mathematical relation we have, that from that we can plot the graph. Okay, so when we are heating, so material property is changing, that's why their gamma is changing. So only one graph they have given in the NCERT, but rest maybe also changes. Okay, so we can say the gamma of the solid changes at high temperature, maybe it will be constant. Beyond height, at some particular temperature it will be constant, but it changes with the temperature. But liquid gamma does not change with, it is almost constant, it does not depends upon temperature. Remember that statement, For the liquid, gamma is independent of temperature. Understood or not? So for the solid, it may change with the temperature. Okay, beyond certain, maybe at higher temperature it will be constant. But for the liquid, gamma is independent of temperature. Okay, for the gases, I will discuss it which factor it depends upon. Okay. Okay. So expansion of the gases, first we have to learn the gas laws, then we will come to the other topic. So first one is the what? Already you have the idea about all gas laws. So first one is the Boyle's law. So what is the Boyle's law? So at constant temperature, pressure of given mass of gas is inversely proportional to or pressure and volume are inversely proportional to each other at constant temperature given mass of the gas. That is also required. Given mass means because the mole has to be constant. So for a given mass of the gas at constant temperature, we can say pressure is inversely proportional to the volume. Everybody know this statement. So we can say at constant temperature, P is inversely proportional to V, or I can say what? PV is equal to constant. Or for the two different condition, P1 V1 is equal to P2 V2. Okay, that everybody know. What is the pressure and density relation? If I want to find the same condition at the constant temperature, what is the relation between the pressure and density? So volume, we can say what? Volume is the mass upon density. So volume is, I can write as a mass upon density. So P into M by rho. That what you will get? Constant. Now given mass means mass is constant here. Mass is constant here. So what we can say? P by rho is equal to constant. Or we can say what? P is directly proportional to the rho. So volume is inversely proportional, but pressure is volume is inversely proportional to the pressure, but density is directly proportional to the pressure. And for the two different conditions, what we will get? P1 by rho 1 is equal to P2 by rho 2. Okay. Okay. So now some graphs. So this is the common graph V and P. In the basic mathematics you learn. What is the graph you will get between P and V? P and V, rectangular hyperbola, because if any relation is like that, y is equal to some constant c upon x to the power n, means n must be the positive real number. So what you will get, when the x is increasing, y will decrease, n has to be positive real number. Then inverse relation is there, one will increase, other will decrease. But in this case, x I cannot take 0. So that's why here I cannot take volume 0, so graph will be the rectangular hyperbola like this. Okay. Pressure and density graph. A straight line. Pressure, and because what we are getting, P is directly proportional to rho, or P is equal to C into rho. So which graph they are asking? Always first we will write the mathematical equation, and from that we can check what is the graph we will get. So here pressure and density I am asking. So pressure, suppose I am plotting on y-axis. So this is the y, C is the constant, and rho I am plotting on x-axis. So what I will get? Y is equal to Cx. Y is equal to Cx means straight line passing through origin. Yes or no? I need the graph between P and rho. So I write the relation between P and rho. So I got y is equal to Cx. Y is equal to Cx means a straight line passing through origin. But we will not start with the origin. Why? Because when you start with the origin, then it means density you are taking 0. Density 0 means volume you are taking what? Volume is the mass upon density. If the density is 0, so volume will be infinity. So or very large. So that's why we will start. The graph will be the same, but we can start with some other point, not exactly at origin. Okay. Pattern will be the same, the line passing through the origin. Okay. Understood or not? Okay. What is this graph? Basically this and this also same relation. Density is the mass by volume. So you'll get the same graph, a straight line passing through origin. What is that graph? I am plotting between PV and P or V. So whatever the value of P, whatever the value of V, but product of the P and V is what? PV is equal to constant. So whether I am plotting here P or whether I am plotting here V, but PV will be constant. So whatever the value of the PV, you will get it is constant. Okay. Understood or not? Because for the at constant temperature, PV is constant. So maybe P value I am taking different. So V will be, P is more, V will be less. Their product will be constant. So that's why it does not depend on the separately the value of P or V. Okay. So one simple question. At constant temperature, a gas is compressed by 25% if initial pressure is P, then find final pressure. What is the answer? At constant temperature, a gas is compressed by 25%. If initial pressure is P, then we have to find the final pressure. 4P. Abhiram, answer is the 4P. 4P by 3. Okay. Next. 4P by 3. Abhiram got confused that what is the meaning of compressed by 25%. He's taking the final volume is the 25. 4P by 3. Okay, good. So here they are saying volume compressed by. Compressed by means that is the delta. Compressed to 25%, then final volume you will take what? 25% of initial. Means if initial is the V, then final you will take V by 4. When they are saying compressed up to or compressed to the 25%. But here they are saying compressed by. Compressed by means extra how much you have changed? 25%. So what is the volume remaining? 75%. So we can say final volume is the 75% of the initial volume. Okay, so V final I can say what? 3 by 4 of V initial. Okay, then we can apply the P1, V1 is equal to P2, V2. P1, V1 is equal to P2, V2. Initial pressure is P. Suppose initial volume is V. That is equal to final pressure P2 and final volume 3 by 4 V. Now V and V cancel out. So P2 what you got? 4 P by 3. Okay. Abhiram, got it or not? What mistake you have done? Okay. Now that is a bubble rise is also the application of the Boyle's law. Tougher question. NEET is not giving the tougher question. Then why you require the tougher question? First, we have to complete the basic of all the law. Then I will give the tougher question. Okay. Vikram, okay. Okay. So we were teaching tougher, but the problem is what? NEET is not giving. Okay. So bubble rise means what? Suppose any bubble, air bubble form at some depth. Okay. Here we will not apply the concept of the surface tension. If they are in the problem, they are giving the surface tension of the water or something they are giving. Then it means we have to use the concept of surface tension. But that we will discuss later. Here they will not give the surface tension. They will say the bubble formed at this depth, when it will rise, and what will be the volume, what will be the radius. Okay. So we don't have to consider the surface tension here. So bubble, suppose bubble form at the depth. Suppose depth is the h. Then this bubble start rising. When the bubble will start rising, what will happen? Because at the depth pressure is more. When it is start rising, so pressure will decrease. When the pressure will decrease, the bubble size will start increasing. Okay. And here we can say whatever the volume, whatever the air inside the bubble, that air is not going out and no air we are adding. Because surrounding is what? Water. Inside it is what? Air. Okay. Inside is the air. So what is happening? Inside air is the gas. So mass of the gas is not changing. Mass of the gas is not changing. So it is a constant given mass of the gas. We are assuming that temperature of the surrounding is constant. So temperature is constant given mass of the gas. Then pressure is direct inversely proportional to the volume. So what will happen when the bubble will start rising? Gas is not added. Only what is happening, that same air is expanding in a more volume. Same air is taking a more volume. So as it is rising, pressure decreasing, volume increases. Okay. So they will ask when it will reach to the top, then what will be the volume, what will be the radius. So this is the application of the what? Boyle's law. Because surrounding temperature we are considering constant. Understood or not? Okay. Okay, so one question we will do on this. If bubble of radius 4 millimeter formed at depth of 70 meter in lake, if it rises to the top, then find its radius. If atmospheric pressure is equal to 10 to the power 5 Pascal. And density of the water you already know. A bubble of the radius 4 millimeter formed at the depth of 70 meter in a lake.